So next, please let me invite Professor Shaozhou Qi from Wuhan University and Hubei University of Economics, China. Shaozhou Qi is very key person in China, involving China's carbon market design, especially Hubei carbon exchange, we call it ETS. So he's a very active economist and environmental economist in China, and he have done many studies in this field. So we are very worried about, we are very concerned about the effect of the ETS pilot in China. What is the function? So today he is going to give us an answer in his lecture. So please, Dr. Professor Qi. Dr. Qi, Professor Qi, please open your mic. Please open your mic. Professor Qi, your mic is mute.
Yeah, hello?
Okay,
yes. Yeah, okay. So, okay, hello everyone. It's my great pleasure to attend this conference in this very special period. Thank you very much for your organization this conference. So today I want to share with you about our working paper with my colleagues, which is about the multi-dimensional assessment of ETS payloads effect in China. It is well known that China started its ETS payloads in 7 provinces and cities before 7 years ago. Up to now, that is almost 6 to 7 years. The 7 ETS payloads generate 1,200 million of carbon allowance every year, being the second largest ETS after EU ETS. In 2017, China, in the end of 2017, China declared start its national carbon market, but 3 years passed, we still worried about whether the ETS will affect the economic growth negatively, and how about its environmental factor and efficiency. All of this we need. It is very necessary to do multi-dimensional assessment for the effect on environment, economy, efficiency, and energy structure, as well as the channels of this effect. Based on this multi-dimensional assessment, try to avoid take apart for a whole mistakes and help the national government to design the national carbon market policies. So because there are 7 ETS payloads in different provinces and cities, the difference in the schemes design in different ETS payloads is very huge, especially the carbon allowance allocation scheme is directly concerned to the oversupply problem of carbon emission allowance. Thus, the allowance allocation methods are crucial to the effect of ETS on emission reduction. And now I am charge of our key project of the National Science and Technology Ministry, which is about the national carbon market allowance allocation methods. So this is our stage research result. This working paper's contribution is that we use the DDD method from the industry subsector data at provincial level to make the effect of ETS policy evaluation more robust. Because the method can further eliminate other time in dividend and observable factor except ETS policy. And the second contribution is that we try to identify the channels in which ETS payload policy leads to carbon emission reduction from the perspectives of energy consumption, energy substitution, and energy efficiency, which is inadequate in previous literatures of studying the effect of the ETS policy. And the third contribution is that we analyze the heterogeneous effect of the different allowance allocation methods on carbon emission and economic performance, which provides experiences for the improvement of national ETS construction. So this is our DTD model that is difference in difference model. We count the ETS, the subsectors covered by the ETS, and the year after starting the ETS patterns. So we collect the data in terms of the 39 industrial subsectors in 30 provinces during 2008 to 2016, which include the carbon emission and consumption, various fossil fuel consumption, and so on. And this reflects the environment effect of the ETS patterns. And the total assets, revenue from principal business, operating profits, and the employment in the sectors covered by the ETS patterns, which reflect the economic effect about the ETS patterns. And then we come to the province panel data of GDP per capita, population, number of granted patents, industry panel data of investment in fixed assets, R&D investment, and so on. So this is our basic results from our BISC model. We could say in terms of the CO2 emission and the CO2 intensity, the ETS pellets and after its start, the subsectors covered by the ETS pellets have a very significant effect. That means the ETS pellets policy reduce carbon emission and the carbon intensity of the covered subsectors. And the ETS pellets policy makes the total carbon emissions, the carbon intensity of the covered subsector, they decline 24.1% and 14.4% compared with 9 covered subsectors in 9 ETS regions respectively. So the positive effect of the ETS pellets is very significant. And in terms of the carbon emission reduction channels, we try to study the energy substitution effect, the energy efficiency improvement effect, and energy saving effect. And this is the result of the channels. We can find that the covered subsector of the ETS pellet mainly reduce carbon emissions through the effect of energy efficiency and energy saving rather than energy substitution. That means the energy efficiency and energy saving effect is these two channels can explain why the ETS pellet policy can benefit the carbon emission reduce. And this is the effect on economic performance of ETS pellets policy in terms of employment and the revenue on assets of the sector covered by the ETS. We could say that the ETS pellet policy does not damage to their employment and the ROA of covered subsectors. Although the result is not significant, but cannot damage. And then we do some robust analysis. Because all the ETS pellets, 7 ETS pellets start since 2013. So we use the 2012 to institute the 2013 and compare if the ETS patterns ahead of 1 year to start, whether it is still significant. So if beta 1 is significant, while beta 0 is not significant, this indicates before the ETS policy implementation, there are no obvious change in explanatory variables, while there are significant changes in explanatory variables after the ETS policy implication. Thus, the change in explanatory variable do result from the ETS policy instead of other factors. So this is the robust analysis result. Compare the coefficients of the interaction terms in carbon emission, carbon intensity, energy use, and energy intensity before and after 2013. We can find that the reduction in the total and relative amount of carbon emission is the derivatives from the ETS policy, initially in 2013 by the channel of energy saving and energy efficiency improvement. That means it is true that all of this improvement and significant because of the ETS pattern start. And then we do some heterogeneous effect of the allowance allocation method because in the 7 ETS patterns, we choose different allowance allocation method, such as benchmark, carbon historical carbon intensity, and grandfather. Different sectors covered by the ETS patterns. In different provinces or patterns, we choose different method. So we try to test which allowance allocation method is better than the others. So this is the result. The subsectors adopted benchmark reduced more carbon emission and intensity compared with those adopting the grandfather and in a historical carbon intensity method. That means the benchmark is better. And the grandfather method may result in weaving fast and hard working, which is not benefit to motivating enterprises to reduce carbon emissions. That's why, in terms of national carbon market, we try to use the allowance allocation method benchmark instead of grandfather. Some data, some sectors covered by the national ETS, because of their data is difficult to collect, we try to use the historical carbon intensity method. We give up the grandfather method. The subsector adopting benchmark and historical carbon intensity method mainly depend on improving energy structure to achieve carbon emission reduction compared with the grandfather in terms of reduction channels. And the subsector adopting benchmark increase their employment compared with grandfather and historical carbon intensity method. And the subsectors covered by the ETS patterns adopting grandfather and historical carbon intensity increase their ROA. So the heterogeneous effect is very obvious in terms of the 3 allocation allowance methodologies. So finally, we summarize our key findings. So in terms of 4 dimensions, that means environmental benefit, economic benefit, efficiency of the ETS patterns, and the energy structure, we could say the ETS and non-ETS sectors and provinces. In terms of the interventional benefit and the efficiency, the ETS patterns is very significant, but the economic benefit and structure is not significant. But at least the ETS pellets did not damage the economic and anti-structure in the ETS pellets regions. And the detailed variables in terms of 4 dimensions, that is carbon emission reduction, energy conservation, energy structure, energy efficiency, carbon efficiency, revenue on assets, labor employment, we could see the ETS pellets. So in terms of the energy saving, carbon emission reduction, energy efficiency, carbon efficiency, all these 4 variables is very good because of the ETS pellets. And the energy structure, employment, ROA are not too significant. In terms of the different allowance allocation methodology, we can compare the benchmark, grandfather, and carbon intensity method. The right line is about the benchmark, because compared with the other 2 methodology, the benchmark is advantage. So the subsector adopting benchmark have a better performance in environmental benefit, economic benefit, efficiency, and structure. And the subsector adopting historical carbon intensity method have good performance in economic benefit and structures. So, because President Xi declared China will try to realize its carbon neutral before 2060, ETS or carbon markets, it become more and more important for China as a market-oriented policies. So just in last month, the Ministry of Environment give a new update national carbon market policies to consult from the society, which reflect that China is fasting its national carbon market building and try to rely on the ETS or carbon market to help realize its carbon neutral target. I think the carbon market is becoming more and more important policies or market-oriented policies in China. So that's all. Thank you.
Thank you very much, Professor Qi. Very impressive presentation, and I think it looks like a very good paper, and we may invite you to submit a paper to Applied Energy later. Also, we know that Professor Qi from Wuhan, and Wuhan is a place identify the virus first in China. So Wuhan also is a very large city with 10 million populations. But the first time the Wuhan city recovered from COVID-19, it's very amazing things. And so we are very expecting that ETS in Wuhan and China will play very important role in the future. So also we leave the questions and comments in discussion time. The next we